Hi, the SI meteorologist Paul Doran here with a brief discussion on tropical weather. We are now well into hurricane season here in the Atlantic. At least officially it has begun on June 1st. There have been no named storms so far. There have been a couple of storms out over the Pacific, but of course we have several months to go, and the tropical system usually reaches a peak in September. I do expect an above normal year, and we ought to get some activity beginning fairly soon. We'll talk over the next few minutes about what parts of the world actually have tropical systems in addition to the Atlantic Ocean. We'll talk about some of the processes involved and some of the specific requirements needed for tropical storm formation. Well, here's a NOAA graphic showing in color the different regions around the world where tropical storms can form. And there's a couple things I want to point out. First of all, note the equator right here. This is the line that cuts across. Of course, it's 0 degrees. And notice that it's very rare, if ever, that a tropical system forms within about 5 degrees of the equator, 5 degrees to the north, 5 degrees to the south. And that's because Coriolis force is a necessary component to cause a spinning motion for tropical storms to form, and it's just insufficient around the equator. So there have been very rare instances where tropical systems actually form within about 5 degrees of the equator. Now, we talked a moment ago about sea surface temperature as a requirement. It has been found that about 80 degrees is kind of the kickoff point for the development of tropical storms. So you have to be fairly close to the equator, but not too close that there's insufficient Coriolis force. So hence we have all these areas, about 300 miles or so from the equator around the world that form tropical systems. Now, the tropical storms are really a way of nature to balance things out in terms of transporting heat from the equator to the poles. What happens is these tropical systems will release heat into the upper parts of the atmosphere after they gather the strength in the warm, moist waters of the tropical oceans, and that heat in the upper part of the atmosphere is eventually transported by upper-level winds towards the poles. So again, basic Mother Nature way of balancing things out across the world is for these tropical systems to develop and transport heat from the equator towards the poles. Now, the tropical systems have different names depending on what ocean they're in, and specifically what part of the ocean. The Pacific Ocean, for example, in the eastern Pacific, as well as the Atlantic, tropical systems are called hurricanes, whereas in the western Pacific, across the date line, they're called typhoons, and here in the Indian Ocean region, tropical systems are known by the name cyclone. Well, here's a graphical representation of some of the processes involved for the formation of tropical storms. First of all, warm, moist air moves over the ocean right here. That's a necessary requirement. Again, the temperature seems to have to reach around 80 degrees or so through studies over the years that have shown that 80 degrees seems to be a magical number. Warm air then rises, and as it rises, it releases heat into the upper part of the atmosphere through the condensation process. That heat in the upper part of the atmosphere is again eventually blown towards the poles by upper level winds, and more warm moist air is then needed to continue this process. So if the tropical system moves over land, this particular influx of warm moist ocean air will be cut off, and eventually the tropical systems will weaken and die. So let's kind of summarize some of the specific requirements of the atmosphere in the formation of tropical systems, and they're kind of outlined right here. Again, the key factor number one is that the sea surface temperature has to be, it has been shown to be necessary to reach around 80 degrees or so. The warmer the sea surface temperature, the greater the chance for tropical storm formation. The atmosphere has to be unstable enough to allow for warm air to rise and then to release heat into the upper part of the atmosphere through the condensation process. There should be moist air near the middle level of the troposphere. If there's dry air intrusion in the middle part of the atmosphere, that'll tend to weaken or even just prevent the formation of tropical systems. Again, we talked about this item D here, where it should roughly be 300 miles from the equator. You can't be within about 5 degrees or so latitude of the equator because of insufficient Coriolis force. A pre-existing near-surface disturbance is necessary. And this last item is kind of an interesting one. Basically, if there's a lot of vertical wind shear, which means change of wind in terms of speed and direction with respect to altitude, if there's a lot of that going on, a lot of vertical wind shear, that tends to reduce or inhibit or completely cause tropical systems to fall apart. And what's interesting about this is it has been found that the Pacific phenomena called El Nino in the tropical part of the Pacific, where sea surface temperatures are warmer than normal, during those years where there is an El Nino, it tends to be strong upper level winds over the Atlantic Ocean, and that tends to reduce or prevent tropical storms from forming over the Atlantic. So a Pacific Ocean phenomena called El Nino can actually reduce tropical storm formation over the Atlantic Ocean. Now here's a plot from the NOAA tropical weather page that shows the probability of named storms in the month of September in the Atlantic Ocean region. Here's the state of Florida right in here, and there's a couple things I want to point out. First of all, basically reaches a peak in terms of probability of a named storm this time of the year just east of Florida all the way up to around North Carolina. In fact, the top two states in the U.S. that get hit by hurricanes are North Carolina #1 and Florida #2. But notice also in September, there's kind of a secondary maximum over the Gulf of Mexico. As you get into the second half of the hurricane season, Gulf of Mexico tends to become more and more important, whereas the first half, the Atlantic Ocean off of Africa and in towards the Caribbean is the most important region for the formation of tropical systems. But by the second half, September and especially October, you get a lot of homegrown systems forming over the Gulf of Mexico where the water temperature tends to remain warm, above 80 degrees, let's say, throughout the early part of the fall. Now here's another NOAA graphic that shows the peak of the hurricane season in the Atlantic is around September 10th. And there's pretty steady progress during the months of July and August, reaching that peak in early part of September, around September 10th, and then a pretty steady progressive drop-off during the latter part of September and into the month of October into November. The top color here represents hurricanes and tropical storms, whereas the lower color just the hurricanes. So we are now well into June. We ought to start ramping up and ultimately reach your peak, at least in terms of climatology, around the early to mid part of September. And again, expect an active year, so we ought to start seeing some activity in the next few weeks. That's it for now. I'm the SI meteorologist, Paul Dorian.